Erythropoiesis is a grandchild or a great-grandchild of hemopoiesis. I'm about to draw the erythropoietic pathway, but we need to start from hemopoiesis. Hemopoiesis means production of all type of blood cell, white blood cell, red blood cell, platelet. Erythropoiesis, production of only red blood cell. This is a continuation to introduction to production of red blood cell. Watch the previous video. So hemopoietic pathway gave birth to erythropoietic pathway. All type of blood cell came from pluripotent hemopoietic progenitor cell. All type of blood cell. This cell gave birth to only two children called the lymphoid progenitor pathway and then common myeloid progenitor cell. This common myeloid progenitor cell is the one we're going to focus on, but let me talk briefly about this one. Lymphoid progenitor pathway is a story of another day, but it finally gave birth to T lymphocyte, B lymphocyte, and natural killer cell. This is about immunity. So the common myeloid progenitor cell at the end is going to produce red blood cell, some type of white blood cell, and platelets. It's going to produce the eosinophil, neutrophil, and the rest of them type of white blood cell. So going further to get red blood cell, which is erythropoiesis, the one we are focused for today. So this common myeloid progenitor cell divided to give us megakaryocyte dash erythroid progenitor cell. At this stage, this cell have given up its ability to produce white blood cell. So white blood cell pathway is gone. This megakaryocyte dash erythroid progenitor cell have the potential of producing platelets and then red blood cell. We are interested only in red blood cell for today. So this megakaryocyte dash erythroid progenitor cell is going to divide into two children called the megakaryocyte pathway, megakaryocyte pathway, and then erythroid pathway. So megakaryocyte pathway, now there's a division of states. Megakaryocyte pathway is going further to produce platelets. The erythroid pathway is going to produce red blood cell. This is about red blood cell production. So at this level of erythroid pathway, two things are going to form. Two things are going to happen. This erythroid progenitor cell, erythroid pathway, is going to form the burst forming unit. Burst forming unit, erythroid cell, and again colony forming unit, erythroid cell. Mark this colony forming unit, erythroid cell. So at the level of burst forming unit, erythroid cell, these cells start to like erythropoietin. Erythropoietin is the hormone responsible for red blood cell production. And at the level of colony forming unit, erythroid cell, the cell have committed to production of only white blood cell. No, only red blood cell. Let's move ahead. So from erythroid pathway to burst forming unit cell to colony forming unit cell, then from colony forming unit you're going to get pre-erythroblast. So pre-erythroblast is the very first cell to resemble red blood cell morphologically. That's under microscope. From pro-erythroblast, we are going to get basophilic erythroblast. They are blasting. From basophilic erythroblast, then we are going to get from basophilic erythroblast, hemoglobin synthesis have started to occur. From basophilic erythroblast, we are going to get polychromatic erythroblast. From polychromatic erythroblast, there's increase in hemoglobin synthesis, and then the cell organelles start to condense. From polychromatic erythroblast to autochromatic erythroblast. Autochromatic erythroblast under microscope is pinkish in color because it has accumulated high level of hemoglobin. And then from autochromatic erythroblast, then we get a reticulocyte. Reticulocyte is immature red blood cell. At this level, at the reticulocyte level, this cell will start to leave the bone marrow. You know that production of red blood cell happen in the bone marrow, and it's not in the yellow bone marrow. You should know better than me. So it start to leave the bone marrow to go into the bloodstream. Inside the bloodstream, 1 or 2 days, this reticulocyte is going to expel its nucleus and become matured red blood cell. Let's recap. Erythropoiesis, hemopoiesis gave birth to all type of blood cell, but we want to target erythropoiesis. So pluripotent hemopoietic stem cell is the originator of all blood cell. It divided into 2 pathways, the lymphoid pathway and then the common myeloid progenitor cell. So lymphoid pathway goes, common myeloid progenitor cell produces red blood cell, some type of white blood cell, and platelets. There is further division along the line that gave us megakaryocyte dash erythroid progenitor cell. At this level, the production of white blood cell is forgotten. It gave up its ability to produce white blood cell. Then further division is going to give us the erythroid pathway, megakaryocyte pathway. It's like they're dividing. So megakaryocyte pathway, this division is by cell division and differentiation. So differentiation in the sense that it's not only division, even though there is a division, but there is also unique symbol or unique characteristics. From megakaryocyte pathway, you're going to get platelet production, story of another day. Then we are in erythroid pathway. This erythroid pathway, erythroid cells will form colony burst forming unit erythroid cell, colony forming unit erythroid cell. At this level, this cell started to have affinity for erythropoietin. So, and at colony unit, the cell can no longer go back, change the mind, and say, you know what, I have to go to platelet level. So, from colony forming unit erythroid cell to pre-erythroblast. Pre-erythroblast is the first morphologically identical or first time the cells start to look like a red blood cell. Let me simplify it. So from pro-erythroblast to basophilic erythroblast. From basophilic erythroblast, hemoglobin synthesis start to occur in a very small one. From basophilic erythroblast to polychromatic erythroblast. Polychromatic erythroblast, the cell organelle start to condense. Of course, you know that red blood cells have neither organelle nor nucleus, and the shape is not even a typical shape of a cell. It is biconcave in shape. So from polychromatic to autochromatic, well, the process is about to finish. The cell have accumulated significant amount of hemoglobin, and under microscope it start to look pinkish in color. From autochromatic erythroblast to reticulocyte. Reticulocyte, immature red blood cell that will now start to leave the site of production into the bloodstream to mature under 1 or 2 days and expel its nucleus. Don't forget, the comment for this video is very educative, very interesting.